Alright, continuing with the quadratic worksheet, we get to the question number 4, and this is outside of the factoring. They're just simply saying express the product. So when we take a look at this, we always have to remember product means multiply. So we're looking to multiply these two things. So I'm going to take x plus 5, which is my smaller binomial, and I'm going to multiply that by 2x squared plus 7x minus 10. And if you remember, how we do this is we take a look at one of the polynomials. So here's a polynomial and here's a polynomial. And what we're going to do is we're going to try to take one of those polynomials and we're going to break it up into its pieces. So I'm going to take a look at the first polynomial and I'm going to break it up into its two pieces. Its two pieces are x and 5. So x is the first piece, and I'm going to multiply that by the whole second polynomial, 2x squared plus 7x minus 10. And I'm going to take the second part of that polynomial, which is plus 5, and I'm going to multiply that by the whole second polynomial, which is 2x squared plus 7x minus 10. All right? So when we do this now, all we're going to do is distribute. And when we distribute, it's this number times all these in here, and then this number times all these in here. So when I do that, I'm going to get x times 2x squared. That's 2x cubed. You're just increasing the exponent by 1. I get x times 7x. That's going to be 7x squared. And then I get x times a negative 10. That's just a negative 10x. So every single x exponent increases by 1. This doesn't have an x, and now it does. The next polynomial, I'm going to distribute the 5 through. So all of the variables will stay the same. The coefficients will just be multiplied by 5. 5 times 2, 10x squared. 5 times 7, plus 35x. 5 times negative 10, minus 50. Okay, my next job is to go through and to find out all of the like terms. So I have 2x cubed. I have no other x cubed term, so that's going to be part of my answer. And I'm done with that term. I go to the x squareds now. I have two of them. I have a positive 7 and a positive 10. That's a positive 17x squared. Now you're adding, so the exponents all stay the same. Those are gone. I have a negative 10x and a positive 35x. A negative 10 and a positive 35 is a plus 25x. And they're gone. And then finally, I just have the one constant for 50, and this is my final answer. Okay, moving on to the back of this. Okay, question 5. On the back, a student was given the equation x squared plus 6x minus 13 and was asked to solve it by completing the square. The first step that was written out is shown below. So what happens between this step and this step is that the student simply added 13 to both sides, and that's the step that you guys should remember, because what are we trying to do? We're trying to isolate the x's. So we have it, okay? The next step is that the next step in the student's process was he had x squared plus 6x. He added some c, some number, to the left-hand side, and he also added that to the right-hand side. State the value of c that creates the perfect square trinomial. Okay, so let's talk about doing this question. If we were going to do this question, if you remember, once we get the x's by themselves, we're supposed to take half of this middle number. Half of that middle number is 3, positive 3. And then we're supposed to square it. So I'm going to put that here. Half of 6 is 3. And then we square the 3, and that gives us 9. And that's what we're going to add to this side, and that's what we're going to add to this side. So we get the equation x squared plus 6x plus 9 is equal to 22. So what is my c term? All right, you're going to tell the person that c is 9. So it states what value of c creates a perfect square trinomial. We're done with that piece. All right. Make sure you answer all questions. And I come down here. Explain how the value of c was determined. Well, you take 1/2 of the number in front of x and square it. Add that number to both sides. Okay? So you're going to state exactly what you did. And then that's it. Question done. They don't even ask you to solve for it. All right? Question number 6. Question number 6 is operations with polynomials. They want you to subtract. Be very careful. Subtract 5x squared plus 2x minus 11 from. So when I'm going to subtract 5 from 10, if I've given the question subtract 5 from 10, that means 10 minus 5. So notice what happens. The order of the numbers switch. So if I'm going to subtract this from this, I'm going to start with 3x squared plus 8x minus 7. And then from that, I'm going to subtract 5x squared plus 2x minus 11. Okay. Now, we talked about how this is done. It's not that bad once you get the order correct. The first polynomial, nothing happens. Just drop the parentheses. The second polynomial, the subtraction changes to positive, and we change every sign that followed. This is a positive 5x squared. It becomes a negative 5x squared. This is a positive 2x. It becomes a minus 2x. This is a negative 11. It becomes a positive 11. And then all you do is combine like terms. 3x squared minus 5x squared is a minus 2x squared. 8x minus 2x is a positive 6x. Negative 7 plus 11 is a plus 4. Guys, we got to get that one right. That's a pretty easy one. Next piece, the vertex of a parabola represented by f of x equals, we have x squared minus 4x plus 3. It has the coordinates of 2, negative 1. Find the coordinates of the vertex of a parabola defined by f of x minus 2. Explain how you arrived at your answer. Well, you can explain it, guys, or you can show it. So we're going to show it here. The one thing that we're supposed to remember is what is a vertex? Okay? Vertex is the turning point of a parabola. It's where the parabola turns. So if I have a parabola that I'm graphing, this here is the vertex. Okay. So this piece right here, this is very, very confusing to us because we're not used to this. And if you remember function notation, whatever is in here, we're supposed to plug in. But what I want you to see is the fact that we're looking for what would be the vertex of this parabola, knowing that this parabola has a vertex of 2, 1. So if you can just think about what they're asking you here, all we're doing is saying, okay, we're going to take the x coordinate and plug it in, and then we're going to subtract 2 from that. And then that will be the number we plug into here. So watch what happens. F of x minus 2 becomes f of 2 minus 2, which is f of 0. Well, f of 0 means come over to here and plug 0 into every one of these x's and see what you get. Well, if I plug 0 in, I'm going to get 0 squared minus 4 times 0 plus 3. This is going to equal 3. So my new vertex is going to be, x is going to be 0, because it's going to be the old x minus 2. And then the new y coordinate that goes with that 0 is 3. And that's it.